Okay, in this video we're going to start talking about how to get the equation of a trig function from the graph, and we're going to do this without a phase shift. So remember, phase shift is just a fancy term for horizontal shift, and we'll talk more about that a little bit later in a different video. But for now, let's go ahead and go through this. So we're just dealing with sines and cosines here. So basically the answer is going to be the equation of a trig function that's sine or cosine. So the answer will be this form or this form here. It's either a sine omega x plus b or y equals a cosine omega x plus b. Okay? So basically the goal here is to determine the values of a, omega, and b. And then once we have those values, we'll just plug them into either one of these, or the correct one of these. Okay? So we have to, part of the process is to determine which one of these are we going to use. Okay? So what we're going to do here in this video is go through example 1 and talk about these steps here. And then there's some more examples for the next few videos. So if you want a copy of this worksheet here with all the examples on it, if you want to follow along with that, click the link in the video description, and then you can open up the worksheet there, and then you can print it out and follow along if you want. Okay, so let's zoom in on these steps here. Okay, so step 1, find the vertical shift b, if any. So b here represents the vertical shift. Remember, that's sort of like a pre-calculus thing, or a college algebra thing, depending on which course you took or where you are. So find the vertical shift b, if there even is one. It might be 0. Okay? Determine whether to use sine or cosine. So step 2 is the part where we pick, is it this function here or do we use this function here? Okay? And it's really not that complicated. That part's not that bad. Step 3, find the amplitude absolute value of a and use it to determine a. So remember, a could be positive or negative. Okay? A could be positive or negative, but the amplitude always has to be positive. Okay, so that's why amplitude is the absolute value of a. So we talked about amplitude in an earlier video. Step 4, find omega from the period. So remember, we talked about period in an earlier video also, and omega we can get from the period, and we can get the period just by looking at the graph. Okay, so we'll talk about that also. And step 5, not really a real step, I guess, just put everything together. So substitute a, b, and omega into the equation you got, or that you chose in step 2. Okay, so in step 2, remember you pick one of these guys, you pick the one that's correct for the graph that you have, and then in step 5 you put all the values, a, omega, and b, into the function you chose. Okay? So let's go ahead and go through example 1 here with these steps. So example 1, find an equation for the given graph. So this is the graph we have, now we're just going to go through the steps. Okay? So step 1, find the vertical shift b, if any. Okay? So how do we find b? Well, first of all, if you look at this graph, it looks like there might not be a vertical shift, right? Because so if you're kind of used to trig function, you can sort of look at it, eyeball it, and see, okay, well the highest point is 4, okay, the highest y coordinate is 4, the lowest y coordinate is -4, so there's probably not a vertical shift. But how do we do that, rigorously? How do we actually show work for that? So in general, actually, b equals the max value plus the min value, all divided by 2. Okay. So what does that mean, max value, min value? It means the maximum value of the function plus the minimum value of the function, all divided by 2. In other words, the largest y coordinate, okay, the maximum y coordinate, plus the minimum y coordinate, all divided by 2. Okay. So that's going to give us our vertical shift b. So what is the max value for this problem? Well, here we already kind of said it. We said the max value is 4. Okay, so the highest y coordinate there is 4. Okay, we see it happens here, and it happens again over here, and it's going to happen again, because remember, these trig functions, sine and cosine, they have that period 2 pi where they just keep repeating every 2 pi units. So anyway, b is the max value plus the min value divided by 2. Max value we just said is 4. Then we have to add the min value. What's the min value? Well, it's -4. Okay, so we see here -4 y coordinate here is -4. So it's the smallest y coordinate on the graph, so that's our min value, all divided by 2. 4 plus -4, well that means 4 minus 4, right? And 4 minus 4 is 0, so that's 0 over 2, which is just 0. Okay, so b equals 0, which means there's no vertical shift. Okay, so no vertical shift. Okay. But again, if you're kind of used to this sort of thing, if you're a little more comfortable with trig functions, you can sort of look at this and see, oh, it doesn't look like there's a vertical shift. But if you have to show some kind of work, this would be one of the ways to do so. Okay? So that's how to find b. Okay, that's step 1. Find the vertical shift b, if any. So step 2, determine whether to use sine or cosine. So now here's the step where we determine, are we going to use this up here or this down here? Okay. So now how do we know which one to use? Okay, so first of all, we know there's no vertical shift, and also we're not doing any phase shift. So the only thing that could be happening now is maybe like a stretch or a shrink vertically, or a stretch or a shrink horizontally. Okay, but we don't really care about that yet. But we want to know, is this sine or cosine? So to answer that question, determine whether you use sine or cosine. To answer the question, which one is it, we have to think about how sine and cosine look. Okay, so let's come to the board for a sec here. We'll zoom out a little bit. So remember what the graph of the sine function looks like. Pull this down a bit. So x-axis, y-axis. If we want to graph the sine function, it kind of sort of looks something like this, and goes a little bit down that way too. Okay, so remember this is y equals sine of x right here. Okay, that's the sine function. Let's maybe zoom out a little more. All right, what about the cosine function? What's the cosine function look like? The cosine function, x-axis, y-axis, and then we'll use a different color here. So the cosine function kind of sort of looks a little something like this. Yikes. All right, not too great, but anyway, so this is y equals cosine x. So what sort of stands out as different between these two? So they do have that same, curvy, wavy shape that we talked about in earlier videos. But what's different about sine and cosine here? Notice that for the sine function, if there's no vertical shift or no horizontal shift, the sine function goes through the origin, right? It goes through 0, 0. The cosine function does not go through 0, 0, okay? So the sine function, this goes, the graph of this sine function, it goes through 0, 0. So this goes through 0, 0. Okay. And the cosine function, its graph does not go through. Doesn't go through 0, 0. Okay, and that's there's a few different ways to think about it, but this is sort of how I like to think about it. If you remember this, that the sine function, the graph goes through 0, 0, and the cosine function, the graph does not go through 0, 0. Just regular sine and cosine without any shifts or anything like that. If you just remember that, then that'll help you here. So if we look at this graph here, so let's zoom back in here, or let's hold it up here. So if we want to find the equation for this graph, we're on step 2 right now, determine whether to use sine or cosine. So we look at this graph, we already know there's no phase shift, so no horizontal shift, and we just found out there's no vertical shift, okay? So, and we look at the graph and we see, oh, it does go through 0, 0, okay? It goes through the origin right there. So, since there's no shifts of any kind, and it goes through 0, 0, are we going to use sine or cosine? We're going to use sine because that's what the sine function, that's what the graph of the sine function does. Okay, the graph goes through 0, 0. And we see here, this graph is going through 0, 0. So it's a sine graph, okay? So that's how we answer that, or that's how we do step 2 there, is basically we say, okay, there's no vertical shift, there's no horizontal shift, so we remember, okay, sine goes through 0, 0, cosine does not, so we look and see, okay, what does our graph do? And we see our graph goes through 0, 0, so it's a sine function. Now you might be wondering, what if we do have a shift, then how does that change things? Well, we'll talk about that in a different example when we get there, but for now, let's not worry about it. We don't want to overcomplicate things yet, or ever, really, but let's not worry about it now. Okay, so the graph goes through 0, 0, so we use sine, okay? All right, so far we have y equals a sine omega x, okay? Okay, so we're going to use this one here, a sine omega x plus b, but we already know that b is 0, okay? B equals 0. So far we have this. a sine omega x. So now we have to know, we have to determine a and omega. Okay, so that's it for step 2. Okay, and remember for step 2 we use these graphs here. We know sine goes through 0, 0. Cosine does not go through 0, 0. Those are the facts that we use there. Okay, step 3, find the amplitude absolute value of a and use it to determine a. Okay, so remember we talked about that in an earlier video. Here, absolute value of a equals max value minus min value all divided by 2. Okay, so remember this is one way of determining what a is, but if you have the graph, you can just sort of look at the graph and see, okay, remember when we talked about amplitude in that earlier video, we said amplitude is the distance from the top to the middle, here from the max to the middle. So what do we mean by middle? Well, by middle, just, you know, halfway in between the bottom and the top, or halfway in between the min and the max. Okay, so that would be right here along the x-axis. Okay, that's going to be at the middle there. So the distance from the maximum to the middle, okay, what is that? Well, the middle is 0, okay, and the maximum is 4. Okay, so this distance here is just 4. Okay, so that distance there is just 4. Okay, so what that means is that in this specific case, the absolute value of a is 4. Okay. So we can just look at the graph and kind of see that. Now, if you have a vertical shift, it's going to be a little more difficult to do that. So it might be better to approach it like this. And then, you know, if you have to show some work anyway, it might be best to do it this way anyway. So let's go ahead and go through that here, just so we can see how that's done. So remember, absolute value of a is max value minus min value divided by 2. Okay. So, so why is this one minus? Well, it's minus because remember, the amplitude gives you the distance from the max to the middle, or really from the middle to the min. Okay, we talked about that in a separate video. Now, when you do max value minus min value, so without the 2 there, max value minus min value, that gives you the distance from the max to the min. Okay, that gives you the distance from the max to the min. But for the amplitude, you only want half of that. Okay, the distance from the max to the middle. Okay, you just want half of that, so that's why you divide by 2. Okay, so take the distance from the max to the min. Okay, do the max minus the min, take the distance between them, and then divide it by 2 to get the distance from the max to the middle, right? Or the middle to the min, same thing. Anyway, that's why that's the way it is. So if we want to show work for this, then that's going to be absolute value of a equals max value, which we already know is 4. Okay, we already know it's 4. Minus, 4, minus the minimum value, which we already know is negative 4. All divided by 2. Okay, so max value minus min value divided by 2. Max value minus min value divided by 2. Okay, the min value is negative 4, so that's why it's 4 minus negative 4. Okay. So 4 minus negative 4, that's 4 plus 4, which is 8. 8 divided by 2 is 4. Okay. So 2 different ways of thinking about it, we get the same thing here. So here we just looked at the graph and said, oh, yeah, okay, this distance here is 4, because that's 4, that's 0. But again, if you have to show work, it might not be okay to do that. It depends on your instructor, really. But also, if you have a vertical shift, it might be a little more complicated to do that. If you know, when you really get used to it, it won't be that bad. But anyway, it's probably safest just to keep going this route here and to keep doing that. Okay, so that's half of step 3. Find the amplitude absolute value of a, and then use it to determine a. Okay, so how do we use that to determine a? Well, since a equals, or sorry, since the absolute value of a equals 4, then a equals 4 or a equals negative 4, right? Okay, so how do we know which one to pick? Well, is it going to be positive or negative? So what we have here is y equals a sine omega x. So what if a were negative 4? Then what would happen to the graph? So if we have a negative 4 out here, so what if, so let's come up here and say, what if a equals negative 4? Then y equals negative 4 sine omega x. Okay. And what does this negative out here do? So remember from your pre-calculus or college algebra days, the negative out here, that's going to take the graph and reflect it over the x-axis, or in general, I guess, and kind of flip it upside down, right? reflect over the x-axis, flip upside down. Same thing in this case because there's no vertical shift. So if there's a vertical shift, you have to be careful about what you're saying exactly, but there's no need to worry about that here. But anyway, in this case, this -4 is going to flip the graph upside down. So we know, so let's zoom back out a bit and come back to the board. So we know that y equals sine of x looks like this, okay? So what if we have negative sine of x? So if we have negative sine of x instead, what's that going to look like? So x-axis, y-axis. So negative sine of x has the same shape, but it's just flipped upside down, okay, reflected over the x-axis. So that's going to be kind of sort of something like this. Oh, terrible. All right, that is a mess. But anyway, oh, that is awful. Okay, so y equals, yeah, there's no saving that one. Y equals negative sine of x. So the point here is that it's really, it's the same thing, but we just took it and flip it upside down. So we see here for y equals positive sine of x, this graph increases through the origin, okay? It increases through 0, 0. So from left to right, it's increasing, it's getting larger. Okay, so if we just focus on this little piece right here, as the graph moves from left to right, we see that the graph is going up also, okay? So the function is increasing. And then here, for y equals negative sine of x, so we'll zoom in on that, we see that the graph here is decreasing through the origin, okay? So we see that as we move from left to right, the graph is going down. So the sine function, if we have the minus sign in front here, this is decreasing through 0, 0, okay? So what we want to do then is look at our graph that we have here for our example, and we want to see, okay, so it goes through 0, 0, and we already know it's a sine function. That's how we know it was sine. So is it increasing through there, or is it decreasing through there? Well, we see it's increasing through there, okay? So that means A has to be positive. Because remember, increasing means positive out here, no negative sign, right? Just like this, increasing, no negative sign. And here, decreasing, there is a negative sign, okay? And here on our graph, we have increasing, so the A out front has to be positive. So that's how we know that A is positive, because we're increasing through the origin. Okay, so increasing through the origin. Okay, so, okay, so this isn't going to happen because of everything we just talked about. So A equals 4 because the graph increases through 0, 0. Okay. Okay. So starting to run out of room, but I think we'll be okay. Now that's step 3, find the amplitude, absolute value of A, and use it to determine A. Now step 4, find omega from the period. Okay, so remember the period is t. Okay, so remember in general the period is t, right? The period is t. We talked about that in an earlier video, and it's always 2 pi divided by the absolute value of omega. Okay? Now, for the purposes of this type of thing here, determining the equation for the graph, we can always just assume that omega is going to be positive just to keep things simple. So really what we could just say is 2 pi over omega. Okay? Because if we were going to assume that omega is negative, then we'll have some kind of tricky things with reflections over the y-axis, things like that. And we can talk about using even and odd properties, and then it's going to mess up the way we handle the sign of A. The SIGN sign, whether it's positive or negative. So that's why, because we already kind of dealt with that here, we don't really have to worry about it with omega, so there's no need to worry there. So we'll just use this here. So t equals 2 pi over just plain old omega, with no absolute values here. Okay, now what? So here, t equals 2 pi over omega. But if we look at the graph, what do we have? Remember, t is the period, right? It's the length of one complete cycle. So how far do we have to go to before a cycle repeats? So let's zoom in on this graph a little bit. Okay, so let's start here at 0, x equals 0. And then if we keep going to the right, tracing around this here, here, right here is where the cycle is going to repeat again. Okay, do we have to start at 0? No, but it's a good number to start at in general. It might not always be the best one to start at, but in this case, it's a pretty good one here, right? Because it's just it's right at the origin. That's good. So if we start here, follow along the graph here, we get back to this point here, and it is going to start repeating after that. Okay. So how long is that? What's the length of that cycle? So from here all the way out to here, well, this is 2 pi, this is 6 pi. Okay, so 0, 2 pi, 4 pi, 6 pi, 8 pi. Okay, so this right here is 4 pi, this right here is 8 pi. So this length here of one complete period is 8 pi. Okay, so t equals 8 pi. Okay, that's the length of one complete period. Now, we could have went from -2 to 6 pi. Okay, -2 to 6 pi. That's also one complete cycle, right? And we get the same answer. The distance from -2 pi to 6 pi is positive 8 pi, right? So same thing there. Anyway, let's come back down here. So we just found out from the graph, just by looking at the graph, we see that t is 8 pi. Okay. So this is how we use the period to get omega. Okay, so we combine these two, okay, and the two of these together imply, that's what this double arrow here means, imply, these together imply that 8 pi equals 2 pi over omega. Okay. So multiply both sides by omega, divide both sides by 8 pi. So on the right, omegas cancel, and then on the left, 8 pi's cancel. That's great. So then what we have is omega, just by itself on the left, equals 2 pi divided by 8 pi. Pi's cancel. 2 over 8 becomes 1 over 4. So omega is just 1/4. Okay? Okay, so that's it for step 4. Find omega from the period. And remember, we're just going to use this, and we're going to drop the absolute values because we already dealt with positive and negative when we did A. And you know, if we're going to worry about positive and negative, then we're going to have to deal with reflections over the y-axis, things like that. And it's going to kind of mess things up with how we did A, and it just overcomplicates things. So we don't have to worry about that really, because you know, you can, if you take omega to be negative, you could just use even and odd properties. Remember, sine and cosine, sine's an odd function, cosine's an even function. So if you take omega to be negative, you can use the odd property and the even property to make omega positive and worry about other stuff otherwise. So anyway, that's why we don't want to deal with or mess with that. So now step 5, substitute a, b, and omega into the equation from step 2. So in step 2, we determined that we're going to use the sine. Okay. So now we have to put a, b, and omega in there. So b is 0, so there's nothing to do there. A, we already found out is 4. Okay, so a is 4, and omega is 1/4. So now the only thing we have left to do is just write the equation down. So that's really all step 5 is, just write the equation. So y equals a sine omega x. So what is a? A is 4. So y equals 4 times the sine of 1/4 x. Okay, because remember, omega was 1/4. And then remember, b is 0. Okay, b is 0, so there's no plus b or anything like that here. So that's our answer here. Okay, so that's example 1. It's really not as bad or as long or complicated as it might seem. It's just, since it's the first example, we're introducing all this, doing it for the first time, so we're going to go through all the details here and talk about each step in depth. So it really, once you get the hang of it, it'll go pretty quickly, especially if there's no phase shift. It's relatively, it's a little easier without a phase shift. But anyway, more examples coming up in the next few videos. And again, if you want to copy this worksheet, check the link in this video and the next few videos. Also, you can click that link and open up this worksheet, print it out, follow along if you'd like. Okay, so more examples coming up in the next videos, and this is our answer again for this example 1.